Hello, welcome to Knowledge of Physics. In this video, I will explain you one of the very interesting and applicable law, Pascal's law of liquid pressure. This law states that the pressure applied at a place on a liquid contained in a closed container gets transmitted equally and perpendicularly in all possible directions. So generally this law tells you that the pressure applied, or if you apply pressure to the liquid enclosed in a container, this pressure is transmitted over all possible direction in the liquid. Okay, and this law is also applicable for the gas as well, but in this video I will be showing you this law. I will be explaining about this law based on liquid pressure, only in liquid. Okay, and Pascal law is established by French scientist Blaise Pascal in 1653 AD. This law is also known as principle of transmission of liquid pressure. And Pascal law is, I have already told you, that very useful in our practical life, especially in vehicles. Principle of Pascal law is used for working principle of the following machines. For example, hydraulic lift, hydraulic brakes, hydraulic jack, hydraulic press. These are the machines that is especially used to lift up or lift down the heavy loads. For example, vehicles, car, bikes and other equipments. And hydraulic brakes, such type of brakes are used in vehicles. And hydraulic jack, hydraulic press, these are the machines where Pascal's law is used. Pascal's law basic. Okay, this is an example of hydraulic garage lift or hydraulic lift, which is used for the lifting up or lifting down heavy vehicles or heavy loads. Okay, okay, let's move on to another figure here. Okay, this is also a hydraulic lift. This one is a smaller piston and this one is larger piston, and liquid is used here in, you can see in blue color. Okay, and pressure is applied from this end, this piston, and output pressure is observed in this piston. Okay, and pressure means here the applied force. Due to the applied force, pressure creates on this liquid, and this created pressure due to the applied force is this is the applied pressure. And P2 here, you can say P2 is the output pressure, and F2 is output force, due to which this vehicle or this car gets off, lifted up, okay, or down. So here this piston on this piston, force F1 is applied, and due to this F1 force, P1 pressure is created. And the area of this cross-section area, it means the area of this piston is suppose A1, okay, and area of this piston is A2, and pressure created here is P2, and force created here is F2. Okay, obviously you can see by observing the diagram, obviously area of this piston is less than area of this piston. Okay, because this piston is smaller than this one. Okay, you can say here the value of area. Okay, area of the piston, the area of piston is 10 centimeters square, and area of this piston is 100 centimeters square. Okay, so based on this figure, we have done here some calculation for the formula, how the force gets applied, how the applied force gets multiplied by this hydraulic lift. Okay, Pascal's law. According to this law, what we have learned is pressure on small piston is equal to pressure on larger piston. This means according to Pascal's law, the applied pressure gets transmitted in all possible direction equally. It means if pressure P1 is applied or pressure P2 is created here, and due to this applied force, then same pressure gets transmitted in all points. Okay, you can say this point, at this point, at this point, at this point, or anywhere. So it means that according to Pascal's law, pressure P1 is equal to pressure P2. Okay, so P1 is equal to P2. It is because the applied pressure gets transmitted in all possible direction in a liquid contained in a closed container. Okay, so I have applied the same concept here, so that here is written as pressure on small piston is equal to pressure on larger piston. Okay, this means P1 is equal to P2, but you know pressure is force divided by area, that is pressure P1, P is equal to F by F divided by A. You can generalize this formula to P1 and P2, that means P1 is equal to F1 divided by A1 and P2 is equal to F2 divided by A2. Okay, so using this concept on this line, okay, this step, we can get P1, okay, here should be F1, okay, not P1, F1 divided by A1 and F2 divided by A2. Okay, F1 divided by A1, F2 divided by A2, because this is not pressure, this must be force. Okay, where F1 is equal to force applied on small piston. This F1 is force applied on small piston. A1 is cross-sectional area of the small piston. This A1 is cross-section area of the piston where force is applied. Okay, and F2 is force created on large piston. Okay, and A2 is the cross-section area of the piston where output force is observed. Okay, so finally what we get from this line is okay, this F2 is equal to F1 divided by A1. This F2 is equal to F1 divided by A1 multiplied by A2. Okay, same expression I have written here. F2 is equal to F1 divided by A1 times A2. Okay, this is equation 1. From this equation, what we have observed is that, or by observing this figure, okay, I have already told you the cross-section area of this piston is obviously less than the cross-section area of this piston. So it means F2 is greater than, okay, A2 is greater than A1. This is the area of the large piston and this is area of small piston. So area of large piston is obviously greater than area of small piston. Then from equation 1, what we get is, if A1 is greater, A2 is greater than A1, okay, then obviously this term is greater than F1. Okay, so which results that F2 is obviously greater than F1. Okay, so we get F2 is greater than F1. This shows you that the hydraulic lift multiplies the force. Okay, thus Pascal law is applicable to multiply small applied force. This helps one to lift up or lift down heavy loads or equipments using small force without any damage. Okay, for example, from this figure what you can see is, area A1 is 10 centimeter square and area A2 is 100 centimeter square. Okay, let's calculate force here. Let's see. Okay, suppose F1 is 10, you can say, okay, 50 Newton. Okay, 50 Newton divided by 10 centimeter square into 100 centimeter square, and how much value you get for F2. Okay, see, 50 divided by 10 into 100. Okay, 100 divided by 10 is obviously 10, and 10 multiplied by 50 is 500 Newton. So obviously F1 is 50 Newton, F2 becomes 500 Newton. See, the force is multiplied by 10 times. Okay, 10 times than applied force. So this is how the hydraulic lift works. Okay, I am here to show you how the hydraulic lift works. Okay, you can see this is applied for, this is small piston, this is larger piston. Okay, and a vehicle is placed on the pan of larger piston, and see how applied force creates pressure on this piston, and this piston is equally transmitted in all possible point here on this vehicle, on this lift. Okay, and ultimately the pressure is transmitted up to here, and see, this pressure creates a force F2. Since the area of this piston is greater than area of this small piston, obviously this results the value of F2 greater than F1. Okay, I have already told you that if F1 has the value of 50 Newton, then F2 becomes 500 Newton for this machine. Okay, and see, and this small force ultimately lift off the heavy vehicle here. Okay, you can see the animation. Okay, this much in this video. Thank you so much for watching. See you in next video. Till then, stay connected with us by subscribing the channel, and if you like this video, comment and share this video. Thank you so much for watching.